Let's talk about some of the hazards that you'll encounter with hurricanes. One of the most dangerous things, and the thing that kills most people, is storm surge. Storm surge is elevated sea level. It's not waves. On top of storm surge, you do get storm waves, but storm surge is just the sea level rising. And this happens because, first of all, there's the extreme low pressure of the eye. So the eye, right, extra low pressure, it's not pushing down on the water as much, and that allows the water to rise a little bit. But then you also have the storm winds pushing some water ahead of it, creating storm surge. And if we look at this, we can see the majority of the storm surge is caused by the winds, but you do get this pressure-driven storm surge as well. And there are equations that you can use to estimate the height of this, but I don't think we need equations in this class. So the height, though, what it does depend on, so just how massive your storm surge is going to be, depends on the speed of the storm. So that's like your forward speed. You know, the hurricane overall is moving forward 5 miles an hour or 7 miles an hour. It also has to do with the speed of the winds, right? Are the sustained winds 39 miles an hour? Are they 89 miles an hour? We also have to look at the fetch. That's the distance the winds travel over water. And then also the orientation and the shape of the coastline is going to affect just how bad the storm surge becomes where you happen to be located. Now the effects of storm surge, like I said, this causes the most deaths in a hurricane. So more people die from storm surge than other hazards. This will damage structures, and storm surge can cause significant coastal erosion. Alright, so storm surge is one of our hazards. We also have the winds of the hurricane. Now the winds are usually the worst in the northeast quadrant. So we have our storm here, and if we kind of cut it in quarters, right? That's the northeast quadrant, and the winds are usually the worst there. And that has to do with the fact that the hurricane is moving forward, and the winds of the hurricane are moving in the same direction. So you actually have to add those together. Over here on this side, the storm's moving that way, the winds are moving this way, so they're actually fighting against each other, so the winds won't be as bad. So your winds are going to be worst in the northeast quadrant. Now the winds can cause a lot of structural damage. And one of the things that they tend to do is they tend to suck the roof off houses. Because as the wind blows here across this arched roof house, it creates kind of a suction pressure. It basically starts pulling the roof and will ultimately could lift the roof off the house. And of course, once these winds are strong, they're going to be picking up all kinds of debris, including the roof it just ripped off, and pieces of trees and whatever else, and it's going to be blowing all that debris around, and that flying debris can also end up causing quite a bit of damage. So when we are talking about hurricanes, and we talk about the hurricane making landfall, that is not this. So this is actual radar stuff from back in 2008 when Hurricane Ike hit this part of the world. And these are simply where the outer rain bands are hitting land. Hurricane landfall is when the eye hits land. So make sure, if you're ever told the hurricane will be making landfall Tuesday afternoon, don't be thinking, well, Tuesday morning I can pack up and leave. You're going to be experiencing half the hurricane before it makes landfall, right? Because landfall is just when the eye reaches. There's all of this that comes before that eye makes landfall. So there's Hurricane Ike. Spinning, spinning, spinning. Ooh, there it made landfall, right? Because now the eye is over land. And hey, at my house, it's not raining. That's my husband. I think he was checking our fence to see if it got blown down in Hurricane Ike. Here's some damage caused by Hurricane Ike. This is off on High Island, I think. And notice this house. It is still standing, but not very many of the other houses are. And that's because Ike had quite a storm surge that, in fact, took out a lot of those buildings. This guy had a house on stilts, but see how it's kind of leaning? And that's because the storm surge really just loosened up all the material it was even constructed on. This was near my parents' neighborhood. You can see the wind knocked down lots and lots of trees there. So hurricanes in this part of the world are something that we're going to have to live with. I mean, they do arrive. I haven't lived here that long, and I've been through, like, I don't know, 3 or 4 of them already. So mitigation, what do we do about it? How can we save lives and property and stuff like that? Well, the best option in a hurricane is evacuation. That's your best option. Just get out of the path of the hurricane, especially if you live in a place like Galveston, right on, on the coastline, because that's the place where storm surge is going to hit, and that's the place where, well, storm surge kills most people, right? Here's the problem with evacuation. The population in areas grows faster than the infrastructure. That means the population can't all fit on the road to evacuate. And you saw that, I don't know how many of you guys might have lived here during Hurricane Rita, when everyone got on the roadway and tried to evacuate. I didn't. I just watched it all unfold. And all the roads were just jammed with people because there are more people who live here than those roads can handle. So evacuation can be really, really tricky, and it can take 2 to 4 days to evacuate big cities. Well, here's the problem. Forecasting hurricanes. Now, this was an extreme example. It's not always this way. In fact, we're not that bad at hurricane forecasting, but depending on the temporal weather patterns, it can be crazy. Like, we don't know, is this hurricane going to head up here, or should we be evacuating Louisiana? We can't evacuate the entire Gulf Coast, right? And so that's a big problem, is accurate forecasts enough days in advance that you could evacuate big cities. So in any case, that's an issue. So what are other things we could do for mitigation of these storms? Well, have better building codes in places, like stronger roofs on houses where hurricanes are likely to hit. Things like shatterproof glass or storm shutters, because remember all that flying debris, right? Restrictive zoning. Like, please don't build 1 foot above sea level, because, 1 foot above, or like 3 feet above sea level even, a typical storm surge is going to wipe out your house. So those are some of the tactics that you can use. Seawalls. If any of you guys, probably most of you, have gone down to Galveston, you've seen the seawall. Seawalls are built right along the coastline with the intention to protect the city behind them from storm surge and storm waves. Now, these can be somewhat effective for small storms in the short term. So make sure that you pay attention to, like, the things I've underlined. Do not be like, hey, can be effective for storms. I'm not saying that. Somewhat, meaning, yeah, they protect the place somewhat, not perfectly. Small storms, short term. Like, this is not a permanent, it's not going to fix everything permanently. And I do especially point out small storms because Hurricane Ike was a Category 2 hurricane, and waves still made it over the seawall in Galveston. What would happen if it was a Category 5 storm? You really have to think about that. The one bad thing, or one of the bad things about seawalls, and we will talk more about this when we go into coastal erosion in a couple of weeks, is they do cause beach erosion. They focus all the energy of the waves right on the beach and will end up washing those away. So let's look at a classic example of a hurricane that hit. and see what happened because of it. And this is the Galveston Hurricane of 1900. And this is the deadliest natural disaster in United States history. Deadlier than any other of the natural disasters that we've talked about or looked at. 8,000 to 12,000 people died in that. And you have to remember, at this point in time, Galveston was a major port city. Houston was not the big city at that time. Galveston was the place to be. And you have to remember, 1900, not like today. Today we have airplanes and satellites watching these hurricanes as they move around. Didn't have any of that at that time. There were, of course, ships sailing in the area, and there were some reports from some of the ships and some of the Caribbean islands. And in fact, weather forecasters in Cuba warned that this might hit the Gulf Coast, but most of the American forecasters thought the storm was going to go along the East Coast. It was going to go like Florida, Carolinas, and that area. So the storm hit 8 September 1900. The island at the time was only about 2.5 meters above sea level. Now, there used to be 4.5 meter sand dunes on the island, but these were removed so people would have an easier time getting to the beach. And those dunes were kind of like a natural barrier for waves, a natural protection. But of course, got to get rid of those so we can walk to the beach easier. The storm, when it hit, was a Category 4. Winds were over 130 miles per hour. The storm surge was 6 meters. So basically, I just told you, the island was only 2.5 meters, storm surge was 6 meters. You can do the math. Basically, the entire island was submerged by that storm surge. There were 9-meter storm waves on top of the storm surge. And the damages as a result of this, and this is updated to 2017 dollars, was about $2.2 billion worth of damage from that storm. And this is, as best as we can figure it out, this is the pathway that storm followed. And the colors have to do with the strength of the storm. So we can see there's this purple here, that's Category 4, that's where it hit. And it traveled quite a ways inland, still as a hurricane and tropical storm. These are some of the damages from Galveston. Pretty much if your house, your structure was wood, well, that's what all this stuff is. Those were buildings. And you can just see how much debris was piled up from that storm. So what was the response? Obviously this was it hit a major city, it caused a huge amount of deaths, and so the response was, let's raise the island. So the island is actually artificially a higher elevation than it was. And it was quite an undertaking. They went basically block by block. If there was a structure that survived, they kind of like jacked it up and filled it in with sediment and soil. So they raised the island artificially and built the seawall. And there you can see the seawall under construction. Right. Well, in 1915 we get another hurricane. Category 4 at landfall. 11 people died in Galveston, 275 total because not all the deaths were right in the city of Galveston. Downtown was flooded with up to 6 feet of water, so downtown Galveston was flooded. Most homes and businesses that were destroyed were beyond the seawall. So most of the damage was away from the protection, the seawall, so they extended the seawall to protect more of the coastline. In the 1970s, homes were built west of the seawall at 1.5 meters above sea level. Now remember, lots of these storm surges are 5 and 6 meters, right? So all of that's going to get flooded. And what happens? 1983, most of those were damaged in Hurricane Alicia when it hit. Now at that time, after Alicia, they wanted to basically be like, no rebuilding here. That's a bad idea. It's just going to be destroyed in the next storm. But pressure from real estate developers forced the state to allow people to rebuild or repair their homes and issue even more building permits to build more homes. 2008 Hurricane Ike rolls in. Guess where the homes, the majority of them that got destroyed or significantly damaged. So we're seeing a trend here. It's like storm hits. We were only a meter above sea level. It was a bad idea to be a meter above sea level. Oh well, we'll rebuild and we'll just get hit again. Sound very depressing, but that's really what happens. It's like, honestly, building a meter above sea level in a place that's going to get hit by hurricanes, not a good idea. That's what I have to say. Okay, so that's hurricanes. But there are other cyclonic storms that exist. There's other spinny storms. Now, hurricanes are tropical. They thrive, they live off heat. Heat is the thing that powers a hurricane. Well, nor'easters, these are strong cyclonic storms that are extratropical. They're away from the equator, they're away from the heat, and these are what we call a cold chord storm. These thrive off cold weather. And what you need to make a nor'easter is you need Gulf Stream low pressure. Now the Gulf Stream is this warm water current off the east coast of the United States. You get some low pressure there, which means you have this kind of unstable air with a lot of humidity in it, right? A lot of moisture in it. And then you have an Arctic high pressure coming close to that. That Arctic high pressure is that cold core that I'm talking about. That's that cold that these things thrive off of. So here we have the Gulf Stream low pressure. Here's our Arctic high pressure coming in there. And remember, if we get some of this cold air wrapped in there, when things cool down, what happens to all that moisture, all that humidity in there? Well, when it gets cooled down, it falls as precipitation. So we get a lot of rain, or in many cases, a lot of snow. And we get strong winds, because remember, winds move from high pressure to low pressure. And the closer you put the high and low pressure, the stronger the winds are going to be. These nor'easters, they form typically from October to April, so they're a wintertime storm. They seem to be especially fond of forming in February. They do not have an eye, so they're a little bit different from your hurricanes. And they're named for the direction the winds initially come from. As the storm is arriving, they're blowing out of the northeast. Or if you want to say it like you're living up in the northeast, it's a nor'easter. These things, because they do have strong winds, can have storm surge with them. So this is a nice typical nor'easter where there's our warmer moist air, that's our Gulf Stream air, and this is our cold Arctic air going into it. And so we're going to get a whole lot of snow coming up into New England area. And a great example of one of these was one called The Perfect Storm. Yeah, it was a movie with Marky Mark in it, but this is what we called the storm that happened back in 1991. 120 mile per hour winds, so that's hurricane force winds there. In fact, it absorbed a hurricane. That was the Gulf Stream low pressure that I'm talking about. It ended up being the remnants of Hurricane Grace, and it just pulled that right into this nor'easter. Average deep water waves. So these are the waves out away from the coast. If we look out, 100 miles, 10.7 meter average deep water waves. The maximum recorded one was 100 meters, which is just, remember, 1 meter's like this. Now imagine a 100 meter deep water wave. This was the storm along the coastline up in Massachusetts. You can definitely see the storm waves coming in there. And so that was the perfect storm. 1991, we're told it was perfect. We're never going to get a storm that's going to be like that again, right? 2 years later, in March, we have the storm of the century. And this actually killed 270 people and caused, in 1993, about $3 billion worth of damages. You can see that's over $5 billion in 2018 dollars. And here it is, right? and it's moved up the Appalachian Mountains basically and just dropped snow all the way up the mountains there. And this was New York. So I just get a kick out of these where we have, you know, the perfect storm, the storm of the century, it's never going to happen again, Superstorm Sandy, never going to happen again. And it's like, well, actually, I'm not that old, and I've been through a number of these perfect super storms of the century. So they do happen. In a minute, or in the next segment, we're going to take a look at what happens with ships in these storms and what happens on the Great Lakes.